So the difference between pressures, I'm going to go ahead and show you again that the difference between pressures is important because remember we're talking about wind here, and wind will go from a high pressure to a low pressure. Now I'm going to talk you through this. We basically, you know that if you climb a mountain that the air is thinner, and also you know that if you climb a mountain, here's my mountain, not only is the air thinner or related to the air being thinner, basically you're going to have a low pressure up here and a high pressure down here at the, near the base of the mountain. Now, what we need to do, or what meteorologists do, is basically to correct for they correct for the fact that this is going to be a lower pressure because of its elevation. And basically they add some pressure onto this because it's at a higher elevation, just because it's at a higher elevation. I'll show you what I mean. So this is a way to kind of normalize or standardize the pressures at different elevations to basically compare apples to apples. So, for instance, your author has a few examples here. We have 3 stations, and they are at different elevations. Station A actually is at sea level. And so in each of these stations, we're going to see that they got out their little barometer, and they measure their pressure. Now, the fact that this location is at sea level, notice that they didn't have to add any pressure onto it. And so actually the value we would see on our weather maps is 1,008 millibars. Okay, well, if we compare that to a station that is at 1,000 meters, okay, now the fact that it's up at 1,000 meters, we know that the pressure, our barometers are going to read a lower pressure, and it does. Can you see where the barometer here is reading 915 millibars? That is the pressure reading. So what is done then to correct for this 1,000 meters is to add 99 millibars. And so the normalized or the standardized pressure, the one recorded, would be 1,014 millibars. So actually you see where comparing apples to apples at this higher elevation, when we consider that it is at a higher elevation, and so it's just inherently less pressure, we see that this actually is a higher pressure, 1,014 relative to 1,008 millibars. See how that works? Now the third station is even higher, up 1,800 meters. Okay, so up that high, notice that even though the barometer reads 840 millibars, we add a whopping 180 millibars to correct for it being at a higher elevation. So the reported pressure would be 1,020 millibars, where you see actually compared to even station B, station C is, when you're comparing apples to apples, eliminating the effect of elevation basically, it's at a higher pressure than even station B. So that's kind of what's being done behind the scenes. Otherwise, when we look at let's see, one way to think of it is, if this is, I'm going to totally butcher this up, just bear with me. There's my Florida. Oh my goodness, that's awful. But as we look at the pressures across the United States, when we, for instance, pass the Rockies, this would always be high. This would always be lower, okay, and then we maybe get to the Appalachians and it would be higher again. And that's not the case. It's automatically corrected behind the scenes. Already done for us. So air pressure changing with altitude, and this is kind of something that we've already talked about in part 6 again. We talked about it in Unit 1, Chapter 1. The fact that the Earth's atmosphere is most dense here and least dense up here. And so this is kind of a few figures from left to right looking at air density and as it relates to pressure. So here's our cute little pressure gauges. Okay, now if we compare A to B, the difference here is you can see kind of like a plunger that actually what has happened with B is we've squeezed that same air into a smaller volume. And as we've done so, we have increased the pressure. We've increased the density and increased the pressure. And so hopefully you can kind of see this needle going this way. And then of course the third scenario here is where we added even more weight. Okay, we have reduced the volume, which increased the pressure even more. As a consequence, I think we could think of it as increasing the density. So there we go, that's kind of what's happening. So kind of along those lines, I think this is a neat little slide or figure. It looks at increase in pressure, I should say decrease in pressure as I have it. It shows you decreasing pressure with increasing height above sea level. So for instance, this is like the first, this is the oops. What we can think of is this is the sea level down here, okay? And so this is like 2 kilometers above sea level, which is what, just short of a mile above sea level. And notice what, in terms of millibars, what is happening to the pressure, decrease in pressure. It's exactly what we've been talking about. And then kind of chunked it up, looking at now up to 10 kilometers. Less than 5 miles then? Okay, notice that in terms of millibars, how the pressure has decreased. Okay, going out then all the way to, kind of changing scale a little bit, but all the way to 50 kilometers. Okay, and see in terms of millibars what how low the pressure is up there. This is, now I'm hoping we got to kind of get our wits about is vertical versus horizontal. Okay, from the Earth's surface, this would be vertical change in pressure from a high to a low. Okay,